Privileged to have Dr. Stephen Labkoff join us. He is one of the most senior people in our medical informatics community. He is a fellow of the American College of Medical Informatics, which is the highest level of recognition that the American Medical Informatics gives to people who have sustained accomplishments in the field. He was trained as in medicine here at Harvard Medical School. He has worked in the Harvard area hospitals, and he spent 12 years with Pfizer, creating a lot of informatics programs. And after those 12 years, he has worked in a variety of different leading companies. He has worked for AstraZeneca. He's also worked for Intelligent Medical Objects, and you saw a presentation a few weeks ago from Andy Cantor, so he was with that organization. And he also did some really great, exciting work with the Multiple Melanoma Foundation, which I think he will also touch upon today as well. He is currently with Quantori. It's a leading company that develops technology for the pharma industry and other biomedical sciences organizations. He has built really large systems. He knows both the technical side of it, but also the pragmatic challenges of trying to put together people, organizations, and data together to advance an improvement in how we do biomedical research. So I think he'll have tremendous insights for you to learn from. And I really want to thank him for making time from his very busy schedule to share his expertise. So, Stephen, let me pass it over to you and look forward to your talk.
Thanks, Yuri, and thanks, everybody. And this is sort of like a homecoming on two fronts for me. I trained at the Harvard Medical School informatics program, a sister lab to Yuri's lab back in the late 90s and mid 90s. And then um, I was at Pfizer from 97 through 2010 and worked in a variety of places, including um, planning and business development and business technology and a few other places in the organization. And my last role there was actually working in this particular group as one of the medical executives in the national at the national level for medical outcome specialists. And I'll go through some of that in just a little bit. Let's skip the slides. Oh, and I did mention I'm one of my hobbies is astrophotography, and that usually is my background, but I couldn't get it to work today for WebEx for some reason. But that's the Veil Nebula, if anybody is actually interested. I shot that on my own telescope at a local observatory. Anyway, I'm going to go through briefly who is Quantori, just my current firm, my background, what is clinical research, and what is clinical research informatics. Then we'll get into registry science. I'm going to go over one of the biggest projects that I've done in my life, which is called the Cure Cloud at the Multiple Myeloma Research Foundation. Sorry, Yuri, it's myeloma, not melanoma, although I have worked with the Melanoma Foundation as well. And then we'll talk about the challenges that really come to bear when, as Yuri was pointing out, in doing and building clinical informatics programs, especially when you're working with patients at a very large scale. And I would encourage folks, I do have the chat opened on the sidelines. If you want to post a question, I'll take a look from time to time to see if there's anything in the chat. And I feel honored. I didn't know that Chris Shute was going to be speaking later today. I thought it was David Bates, but and feel honored to be on such a platform with either of those gentlemen. And they're also very senior folks in the field. So Quantori, very briefly, we're a clinical informatics consultancy. We work all up and down the pipeline in pharma. We work from early discovery through late commercial and pretty much everything in between. I was brought on board to lead the life sciences work around phase 2B and later, and especially with bringing real world evidence to bear for the organization. And we've done that by setting up a practice, one of the practices in the consultancy around registry science. And we'll be digging into that very deeply in just a few minutes. But we also handle a lot of things like building systems that will handle genomic information, proteomics. We build high performance computing clusters. We do things in GCP and AWS. And basically, if there's anything to be done in life sciences, our firm is able to put it together and build it. And that's because we have like over almost 800 folks working on the back end from all walks of life in the space, from clinical informatics through programmers, through data scientists, and we basically have the whole stack top to bottom. Um, just give you a little more about my background. I'm a physician by training. I trained at the University of Pittsburgh for my medical residency. I did a cardiology fellowship. As I mentioned, I did my training in informatics at Harvard, and then it was 13 years actually, Ori, at Pfizer in all these different departments. A year at Deloitte, and then some time at AstraZeneca. And the only thing that really got my attention when I put this slide together was, oh my God, I've been doing this a long time. And that's probably getting to be too long. Um, so let's talk about what clinical informatics actually is and how it's defined. The NIH defines it as patient-oriented research, research that's conducted on human subjects, um, that is done where an investigator directly interacts with humans, as opposed to animals or um, just working in a lab. And it's basically around looking at mechanisms of human disease and therapeutic interventions and through clinical trials in ways to develop new technologies. And that could be new technologies that might be in terms of medicines. It could be in terms of um, devices. It could be in terms of even digital medicines these days. It has a lot to do with epidemiologic and behavioral science, and it does have a focus on outcomes, which is in some respects somewhat different than other areas of informatics, which sometimes looks more at the um, looks at the outcomes slightly differently. One of our colleagues, Yuri's and my colleagues, Phil Payne and Peter Emby at AMIA, crafted a more precise definition of clinical informatics. It's a subdomain of biomedical informatics concerned with the development of applications and evaluation of theory and methods and systems to optimize design and conduct clinical research and analysis, interpretation and dissemination of information that's been generated. That was listed in about 10 years ago, 12 years ago at JAMIA. And that was sort of a seminal paper because it launched at our peer organization at AMIA. It provided a new venue, and they started having an annual meeting around clinical research informatics. And it turns out, of all the AMIA meetings that are out there, that's probably the best one that I can think of if you're in this space. It really touches life sciences in a way that is very deep and impactful, and it looks at things up and down the line from clinical genomics and how proteomic studies all the way through outcomes research and real world evidence and everything in between. And if any of you are thinking about diving a little deeper into informatics, the American Medical Informatics Association would be the place to do that. And they have several meetings a year, but this one here, the Clinical Research Informatics meeting, plus the annual meeting, which is generally in November, would be the places to make a pit stop and learn. You can get some of the best learning short of going back and doing a fellowship at these meetings. Just visually, where does clinical research informatics fit? If you see in this graphic, which is from that paper by Payne and Emby, it's sort of in the center there. It basically sits away from, in between basic research and then basic community practice and everything in between. And it's a wide swath of types of research that are done. And with regards to life science companies like Pfizer, it basically cuts through early clinical studies, which might be phase 1 through phase 2, all the way through phase 4. And then you've also got the epidemiology and health sciences research, health outcomes research, sorry. So real world evidence fits into this as I would say sort of a subcategory. And if you want to define real world evidence or real world data, it's data that is actually generally collected for some other primary use in the world and is then taken out of that context, put into a secondary use context for other purposes. And examples of this would include medical records. So at no time when you see a doctor is the medical record that's being collected in your behalf intended as a primary use for outcomes research. However, its primary use is clinical care. You want your doctor to be able to care for you, look back at the information he's collected, and to understand what's changed in your particular trajectory in your clinical disease or your clinical journey. And the doctor has to be able to make heads and tails out of that in such a way that he or she is able to take care of you. But the exhausts, so to speak, from that work is in the domain of secondary data use, which would include things like outcomes research or epidemiology or clinical trials matching. All of these things are secondary applications that can be done if the EHR data is available in an anonymized way and in a way that can be uh, brought to bear for those secondary purposes. And it's one of the reasons why there's a lot of attention here, because um, there's an awful lot of use cases that can be used for the medical records data. In point of fact, one of my papers when I was at Pfizer in 2008 was published in JAMIA, and it outlined 42 different use cases that Pfizer identified at the time that could be used with medical records data. 42. And frankly, I've been spending most of my career since 2008 kicking the tires on those use cases and ticking them off one by one. Other kinds of real world evidence include, medical claims, and you all are very familiar with that, I'm certain. Um, Billing from insurance companies and PBMs, but those records can be used for things like, again, outcomes research and um, life science representative targeting. So rep targeting for sales. Patient reported outcomes is another area of real world evidence. This is things like patient satisfaction surveys or patient points of view on therapies, and that's highly utilized for outcomes research. And then one that you all probably don't think about all the time is consumer purchasing data. And if you take that, that's like what data you get from Catalina that's at the grocery store or the Walgreens. But if you match that up with medical records data or claims data or even genomics data, you actually might find that the overlays of those 2 or 3 or 4 different data sets can provide a much richer view of what's possible. And when you start bringing that all together, it's known as multimodal data. So collectively, when you bring more than one of these data sets together, it's a multimodal data set. And those are really what's been getting a lot of attention in the past 5, 8 years, because it's one thing to interrogate just medical records or just medical claims or just PROs, but you can only get limited types of insights when you do that. So from a medical claims perspective, and when I was at Pfizer, most of the times that we were using data, it was claims data from IMS Health, which is now IQVIA. And you could do a lot of stuff with that data. But what you could never do from that data is you could never tell what was a creatinine or what was a glucose level, or did thyroid hormone TSH levels change over time when they were put on thyroid hormone replacement therapy, or was there an outcomes change in a cancer where a biomarker is recorded and see a change in the biomarker. None of that is possible when using medical claims data. But likewise, if you're looking at medical records data, you can't really tell what things cost. I defy you to look at an EHR and tell me how much did that stay at the hospital cost? How much did that X-ray or MRI cost this medical system? And that's where you start bringing multimodal data sets together, because then you can ask questions like, of these patients with stage 2 breast cancer who have metastases to the lymph nodes, what is their average cost of stay for a hospitalization? And you can only do that kind of a query if you bring together multiple modes of data with EHR and claims. And that's really how this begins. Okay, I'm getting text in the background. I don't mean to be interrupting with that. So let's dive a minute into registry science. So registry science is an area which is sort of a sub area, and it's effectively, how do you look at different types of patients' journeys? Now, I'm assuming it's a patient registry at this point, but look at their disease and mass over time, and how does their course vary with their genomics? How does it vary with the addition or deletion of different therapeutics? And there's different types of organizations that care about these things, and they range from patient advocacy organizations who have a specific interest for patients with, in my most recent job, multiple myeloma, but they could also be, pharmaceutical companies who are doing research and trying to find patients to put on trials, and they could use the registry as a source of identifying patients for those trials, provided there's a way to get back to the patient. Analytics firms love registries because it's highly curated data. And the point of all this is that you are trying to use registries to get highly refined data that the EHR simply doesn't collect, because when the EHR work happens, the EHR is again, collecting data for the sake of care. And by the way, it doesn't collect everything in a way that is homogeneous, and EHR data tends to have a lot of holes, whereas the registry is highly curated and tries to fill the holes before the data set's actually ready for use. Are there any questions at this point? Let me just pause a second.
No questions up to this point, but everything's been good so far. Thank you.
Great. So, what are some of the typical use cases? They involve things, and this is assuming multiple types of registries that could be used for observational studies, for regulatory, for REM studies, for regulatory requirements. It could be done for patient advocacy or clinical decision support. You can use a registry actually to generate rules by looking at what's happened, and then that can be used as evidence to create clinical decision support rules. And there's probably many more use cases for registry data than are even listed here. And it's all because the registries collect the data for them in a much more rigorous way than EHRs do, and certainly claims ever would do. But what is the real difference here? So we'll dive a little deeper here. Electronic medical records are generally broadly focused on episodic care. They very seldom try to look at what's happening among similar patients with similar diseases. They are looking specifically at individuals. But a registry looks at the aggregate. A registry takes into account what's happening for a group of like patients or like individuals, or like a registry could even be for a device for that matter. You can register, when I was practicing cardiology, we had a registry for all of our patients with pacemakers or defibrillators, and you could see if there was errors or problems or recalls, and the registry is useful for things along those lines. But it's all because it's all aggregating the data from those multiple sources. In terms of, is one better than the other? And the answer is no. They have different purposes for life, and they have different utilizations. And I wouldn't say there's one that's better or worse than the other, but it depends on the use case that you're trying to apply across into it. If you do look at registries, there are two examples. These are examples of different kinds of registries. There's some that are research focused, some that are patient focused. The work I'd recently completed at the Multiple Myeloma Research Foundation was a patient-centric direct-to-patient registry, which in fact means that the direct focus of the registry was for the actual patient was the primary area of study, and it didn't go through an academic organization like Harvard or Harvard Medical School to collect and curate the information. It was being collected and curated directly from the patients, versus a research-centric registry, which might be run by Dana-Farber Cancer Institute, for an example, who may be collecting information on some rare sarcoma, and they want to collect all the information they can around patients with all that rare sarcoma, but that's going to be collected in a different way, a different means, and it may or may not be collected with the patient's consent, because they could potentially collect it from anonymized data, but it would be useful for other use cases. One of the patient-centric use cases that we were trying to do with MMRF, we're trying to actually get the patient's genomic signatures created and then match that with clinical trials based on genomics. There's a question here. It says we have one question on EHR registries. How would you consider those in the context of your slide showing data from EHR separate from a standalone registry? Unfortunately, Lance, I don't quite understand the question. Maybe someone could elaborate on what they're asking here.
I think if I can clarify the question a little better is, so like in Epic or Cerner, you might have a registry like Healthy Planet is Epic's,
I see what you're saying.
Registry. Cerner is Healthy Intent. How would that compare to something that's more of a standalone registry out there, for example, Corona for like in rheumatoid arthritis, that's collecting data from multiple centers, and it's kind of its own standalone registry that might be put up in association.
Yeah,
or
so
something.
let's talk about that. And basically the differences would be, unless there's very specific data curation that's being put into that Epic quote unquote registry, it's highly likely that you're just going to be trying to aggregate fields from the freestanding electronic medical record. I haven't seen Epic registries, and that doesn't mean they don't exist, where they have spent the time and energy on the full breadth of curation, which means if there's a missing data field, they don't chase it. They don't try to find it. They'll just present you for what they have. And it's sort of almost like looking at a cross-sectional report across all of Epic to sort of see what's in that particular instance. Whereas if it's being done, at a third party, such as MMRF, they took data in from multiple Epic institutions and Cerner and NextGen and Meditech, and they aggregated all that medical information, and they went to great pains to try to fill in the holes where it was possible. So the difference is really there that, number one, you'd be looking at one individual system or healthcare system, perhaps. Unlikely you'd be able to aggregate across multiple systems using an Epic system, at least unless Epic is really harmonized across multiple institutional CDRs, clinical data repositories. Whereas the whole point of building the clinical registry outside of Epic or another EHR is that there's a tremendous amount of energy put into filling in the gaps and curating it so it's all like for like information where possible. Does that pretty much answer the question?
Yeah, that was excellent. Thank you.
Yeah, I think that the Epic and the Cerners of the world are trying to float themselves as registries, but it's sort of a poor man's registry because ultimately the sample is going to be limited to that institution only or to that network of institutions. And you're just not going to get the same kind of cross-section as you might and diversity as you would in a national registry for like cystic fibrosis, which is one of the largest across the country. So, when you go to build a registry, what are some of the things you have to think about? And it turns out that building a well thought through, whether it's direct to patient or other medical registry, there's a lot of steps. These are not simple systems to stand up. So Epic would love to be able to overlay their system with, this quote unquote registry application. But again, I don't think it's going to be nearly as rich as they would hope. You need to think about realistic scoping. When you go to build something like this, you need to sort of understand what questions you want to ask of the registry, sometimes as much as 3 to 5 years before you're actually ready to use the data. In large part because you have to sort of presuppose, and everybody uses the expression, go to where the puck's going to be. When you're building and architecting a registry, you really got to pre-think what questions you're going to be thinking about to the best of your ability, because in 3 to 5 years, medical science might morph, change direction. So it's quite important to have realistic scoping of what you want to do, so you either don't spend too much money and energy up front, but you do have flexibility in the system so you could add things down the road. Understanding the needs, they need to be realistic and achievable. One of the downsides of the registry that we built at Myeloma Foundation was they made it almost a little too complicated than it needed to be. And they wanted to actually send phlebotomists into patients' homes, collect blood, and then move the blood to the lab, and the lab data then would go off to a pathologist, and then the pathology information would get read into a report, and that report would go to a secondary genomics counseling service to then present patients with a human readable, patient readable report so they can understand their genomics. All due respect to the MMRF, and I ran that program for 3 years of my life, it didn't need to be that complicated. And understanding where you need to put your energy is important as you're building this out. They could have accomplished probably more had they not tried to give patients back clinical data on their genomes. That prevented an awful lot of extra work that I'm not sure is ever going to pay off for them. But, it is what it is, and it is, one of a kind. You do need to worry about standards. One of the beauties and pitfalls of doing this kind of research is, so a beauty of the Epic overlay would be all the data would be in a standard format. And one of the challenges for a national level registry is that you may or may not have data coming into that's going to be using standards. Now, you may have heard from previous talks about HL7 and FHIR and the U.S. clinical data for interoperability, US CDI. These are standards, some of which have been around a while, some of which are somewhat new. but being able to bring all that data together relies on these standards being adhered to. And it's only been since last April that USCDI became the law of the land. And I'm curious to see personally how soon the work from the USCDI is going to percolate all the way through. Data governance models are another thing that's really important. Coming up with a model that works, that you can then govern, who has access controls, who can manage your consent forms and user security. All these things are considerations. And as I mentioned earlier, you need to architect for the future. Oh, and one thing that people don't always think about is documentation. When you build giant systems like this, it's incredibly unlikely that anybody is going to be on the project at the beginning and at the end. And as a result, you've got to build it in such a way that people can roll on and roll off the project with enough documentation that they don't need to start from scratch every time somebody rolls onto the project. And thinking about sustainability at the beginning is another piece, and coming up with a financial model that is viable is one of the hardest things that's out there for this. Registries generally are in service for years, not months and not weeks, and you need to track things over a long, lengthy period of time generally. And that means you've got to be able to pay for the services, which in these days means you got to pay, Amazon or Google or Microsoft for time on their virtual systems in the cloud. And if you don't build for sustainability, you could have done the greatest front end and you can have all the data interoperable, but if you can't sustain it for more than a few years, you're going to have a big problem. So you've got to think about all these things as these systems are being brought up and online, and they need to have a think about the long-term sustainability. So this is sort of an overview of what all this looks like. It starts off with a discovery phase and figuring out what the right architecture is, then leaving some of it on the cutting room floor through prioritization, and then you go to a build system where you implement the whole thing, and then from there it becomes a recruit run phase where you're trying to actually build patient population into the registry so that you have enough patients to track on whatever you're interested in. And it's a cycle, because as you put more patients in, you start looking at the data, you can start sort of seeing, do things need to change? Did you forget some fields? Did medicine change? You need to add some fields. All of these things tend to be things that become this cycle of how you build. And the challenge also is that you don't want to perturb the system too much by adding too much along the way, because then you're going to have drift in your system. And when you have drift, that means that you might have 5,000 patients in your registry, but if every 500 patients you've changed the data model, you may only have 500 patients at a time that have the same data model, and it makes analyzing it and rolling it together more challenging. This is sort of an example of a registry architecture, which would have multimodal data coming in, which might include imaging and genomics and labs and all these different things. And the point of bringing it all together is that it's not even just one data system. It might be across multiple systems. It might be across Google Cloud. It could be across a centralized server, or it could be across Amazon. And all of them might have to work together in order to get all the insights out of it that are interesting. And having the forethought of how to settle on standards and how to settle on how you put all this together is actually super important as you get these things off the ground. So this is an overview of just some example registries that I'm aware of, and there's many out there, in terms of what they have going on in. And when you look at the descriptive characteristics, who's got what, this is coded where green is they have it, yellow is they have some of it, and orange is they have none of it. Maybe that should have been red. But if you look at the Cure Cloud, for example, the Cure Cloud has a lot of different types of data. It has longitudinal patient information that's done by human abstraction. It's got patient surveys. It's got clinical data from EHR that been abstracted. It's got genomics and immunologic data, or that's yellow because it was coming online as I was leaving. It doesn't have claims. It does have PROs. It happens to be direct to patient, but it is supportive of researchers. And that it has got a sustainability model that is built around selling the data to life science companies, and Pfizer actually is a customer, I believe. And that gives the ability for the whole thing to continue in a positive flywheel. If you look at others like the Hackensack COVID model, for example, so Hackensack during the bits of the pandemic put together a COVID registry. Unfortunately, that COVID registry, it wasn't even longitudinal. It was a single snapshot in time to look at cases of COVID across their institution and a few others, but it didn't track things longitudinally, at least at the time when it was being brought up. And that left it to be much less usable and useful. The Cystic Fibrosis Foundation is an interesting use case. They have it's a direct to researcher registry, and it asks, get this, 2,000 questions for every patient that's put into the system. Their clinical research data form intake is 2,000 fields. So it's very rich, but I'd hate to be the poor soul doing that. But it is one of the richest registries. Yeah, whoever's saying 2,000, yeah, it really is 2,000 fields. And it's one of the most robust registries around cystic fibrosis that exists. And it has been in service for more than 40 years. So, yeah, nobody there has started on the same project who's still with it. That's for damn sure. Not after 40, and it's more than 40 years. So data, getting data into the system is a challenge because depending on where the data is coming from, you might have to get patients to type things in, or our clinical research assistant to do data entry. Many times it could be a live work, but getting all this information in is challenging. And if you're trying to say, we'll just slurp it out of getting the data out of an electronic medical record, I'm going to tell you that's not easy either, because the interfaces are not clean. You can't really attach to them and plug right in like you'd think. And it makes the ability to bring all this information together very, very challenging. Automated data capture. This is going to be talking about the issues around some of the standards that are out there. I mentioned the US CDI and FHIR. These are data exchange standards that are trying to both put forth a communications standard in terms of FHIR, as well as field standards that define what does a glucose lab mean across the entire United States, or what does a problem list mean across the US. And if US CDI is successful, and it ought to be, it's been put into law and people have to abide by it now, that ought to help things a lot. Interoperability remains one of the most difficult challenges into doing clinical research on especially medical records data, but in every data set. And it's funny, I went to a lab it was a conference in Boston recently called Lab of the Future. And I've been very deep in this space for a long, long time. And I sat through the Lab of the Future workshop, and I was kind of taken aback because the lab space is dealing with almost identical problems. They were complaining about interoperability and no data standards and field definitions. And I'm thinking, did I walk into the wrong meeting? And it turns out that it doesn't just extend to clinical data, it extends to laboratory data too. Now, the radiology space has actually gotten their act together. Oh, I don't know, 20 years ago, maybe 25 years ago, they decided to settle out on some imaging standards, those known as DICOM. And the DICOM standards have been around for, I want to say, since the mid-90s. And that actually prescribes a uniform way of, what does it mean to show a digital chest X-ray? What does it mean to do a digital MRI? And how many pixels per frame are there? And how is the frames broken down in the data stream? And all those things have been sorted and agreed upon using DICOM. And for whatever reason, DICOM is really, yeah, thank you, Lance, DICOM, that's right. I wish I actually remembered what DICOM stood for, but I'm sure somebody can Google that, the background. But that's one area where interoperability is far better. But there are still challenges in radiology, because if you're trying to roll data together from two different MRI instruments, well, it turns out that even if they have the images are the same, the way the images are created, and if they don't have standardized magnets and standardized magnetic fields, and if they're doing fMRI and they don't use the same standards there, it becomes another challenge because you can't roll that data together smoothly. And it remains one of the big Achilles heels of our field of informatics. And I predicted it would keep me employed through the rest of my career, and it'll keep probably my kids employed through the rest of their careers. So I don't think that one's going to get solved anytime soon. This is a shot of the USCDI. If you're interested in this, I would recommend going to the healthit.gov, which is the Office of the National Coordinator. You could look at this, but it's trying to get certain areas of data collection sorted in a way where they're defined and well defined. So this is an effort to sort of harmonize across Epic and Cerner and NextGen and Meditech and all the other EMRs that are out there, come up with a common nomenclature and a common way of describing these fields so that you can actually do like for like comparison and roll this data together. There's a lot to read on this site, and there's a long PDF file that the link is on this slide. FHIR, Yuri, I don't know, did you guys have a talk on FHIR at this point, or do I need to go into detail on FHIR? Because I do know
Briefly mentioned that that'll be part of the final module, so not in any
I'll
depth.
skip FHIR. So metadata. So what is metadata? Metadata is the information that is layered on top of the information that describes it. And you can think of metadata like when a doctor sees you and writes up a clinical note, they actually need to put a code on that note to get paid, which is generally an ICD-10 code. And that ICD-10 code becomes not just a billing code, but it becomes metadata. It's data about the data. It's information about the data. And there's many, many different types of metadata vocabularies and ontologies that are out there. A few of them are listed here, ICD-10, it's SNOMED and RxNorm. And these metadata ontologies and vocabularies are incredibly useful for being able to do medical outcomes assessments, because you can then roll the information together and make heads and tails out of like for like information. And if you heard from Andy Cantor, then his whole company was all based on data harmonization using medical metadata and putting those metadata fields into practice in medical records. That's what IMO's specialty is. And I actually used to work for IMO and was trying to build out metadata applications for their programs for life science companies, because I believe that if you guys are doing medical outcomes assessments and you're bringing in medical records data, it is so much easier to do an analysis if you've got metadata codes in the record versus having to figure out, well, does this mean that, or does that mean this? And are they like for like, and can you roll them together and aggregate it? It makes, as I said, I used to be a medical outcome specialist, at Pfizer. I know how painful it is to have have to do that. And many times there aren't good tools to put that stuff together. I'm looking at the clock, and I maybe get more slides than I should have had. You wanted me to talk for about 45 minutes. We're at the 45-minute mark. Maybe we should stop and have a discussion. The rest of my talk is going to be about trade-offs and challenges in building registries. Yuri, I'll ask you, do you want me to continue, or do you want me to stop for conversation?
Why don't we ask for questions from the audience, and then if we have a few more minutes, you can maybe do a few more slides. But Lance, do we have questions from the audience?
I think we're good for the moment. If you want to go through a few more slides, I think that, to be honest, we're trying to work a lot around registry. So I like the idea that the trade-offs slide you had there, and maybe if there are a few things around that, I think that would be good. And then I'll keep polling to see if there's some other questions. But everything's been good so far, but no like specific questions.
All right, I'll put the slides back up. Hold on. Well, if you're interested in registries, I've set, as I mentioned, I set up this registry practice at Quantori, and we can be very useful to folks like you. And given that I've actually been in your shoes, I'm going to guess that I'm going to be able to anticipate many of the problems you guys are going to try to sort on. So some of the trade-offs with data entry schemes, when you do things like with patient entry, one of the pros is that you get very accurate demographics, as an example. But the downside is that if you're trying to do this with 65-year-olds and older, they might not be able to type properly, or they might not be able to get to the website as well as you might think. It turns out that even with, as well as the internet is percolated through society, the older population in 60s and 70s still aren't as adept at this as you might think. It tends to be error prone. Another challenge that we had with our registry was we had people cheating to get into our registry. They were trying to game the system and get in, and that meant that we had to figure out new ways to actually curtail their data entry to make sure that they screened in or out more accurately than we did at first. A positive on the other side of it, though, is you can ask very specific questions and get very personal about the questions you're asking in PROs, as an example, or adverse events. But the downside is that, there may be issues around matching up with metadata and getting it to be able to be rolled together. So there's good things and bad things around, having patients do their data entry. There's trade-offs for different clinic. If it's a clinician entered data, so if clinicians are doing it, that's going to probably be the highest well-curated data you can get. On the other hand, you're then using the most expensive person in the medical ecosystem to do data entry. Not only are they the most expensive, but they like it the least. Most clinicians that I know abhor working with Epic, not just hate, but abhor it. So just in the hour before this call, I was ranting at my local radiologist because I spent 15 minutes on 4 separate calls trying to get a personal scan ordered for myself. And I finally got a manager on the phone, and she explained, oh, they just went live with Epic, and it's now costing them 4 times the amount of time it takes to do one new radiology rec. And all I did was sigh and say, I feel your pain. I know what you're going through. But I said they need to figure it out because this is not useful. So if you were running a business, would you want it to take 4 times longer for your staff to bring a new customer on board? And I would think the answer is no. And the problem with this is that this is one of the problems with relying on clinicians. If you do things with clinicians, you might have to rely a lot on natural language processing. We didn't get into NLP as part of this. Hopefully, Yuri, you've got somebody else talking about NLP, the good, the bad, and the ugly. And there's a lot more bad and ugly than there is good, at least as far as I'm concerned. It's not the best technology, even though people will rant and rave and say good things about it. It still has, even the best systems can't really approach much better than 97% accuracy. And in a medical record situation, 97% accuracy is nowhere near what's needed, in my personal opinion. If they misread the word hyper for hypo, or they misinterpret something the wrong way, it's 3 times in 100 words, let's say, that they might get wrong, and that could have devastating consequences. So NLP is not my favorite thing for data entry, with one exception, which would be limited terminology or limited vocabulary systems. There, it actually does not a bad job, but if you're looking at general data entry, it can be very problematic. Let's see here. Registry data entry schemes. We've covered a good chunk of this actually in some of the things we've already discussed. Just to give you a sense of how complicated some of these are, this is a very simplistic registry. And this is showing how you collect blood specimens, get them organized, and get the data sent into the system. This also is showing how PROs are done. But the point of this slide is to show that it's complicated. And every time you see an arrow going from here to there, that generally means some kind of information is going from here to there. And that means that you have to build interfaces to move the information and keep it accurate. You've got to worry about whether or not the data gets to its destination intact. So you might think, oh, the internet's great. We can send data from place to place. Well, that's true, except when we were doing it at the MMRF and trying to move around human genome data that were being measured in gigabytes per file, different things were breaking down, and we weren't getting complete transfers of these large multi-gigabyte data files. And there are ways to prevent that, but you've got to go to special pains to make sure that the data get from A to B intact. And it's things that you don't think about like that, but if you're architecting or building something like this from the ground up, you need to worry about stuff like that. This is the Cure Cloud's data model. And if it looks complicated, trust me, it's exceptionally complicated. And I don't remember how many tables are in it, but I'm guessing there's upwards of 30 tables in this. And that doesn't include the genomics or the proteomics side of things. This is just the electronic medical record data plus the intake data. So there's a lot going on inside of these systems. This is the workflow. I won't go into that since we're running short on time. And this is the most simplistic view of what's in there at the moment. It's got patient donated data, electronic medical record data, genomic panels from the Broad Institute. There were some exome panels that are being brought up for circulating myeloma cells, and then immune profiles through CyTOF and single cell RNA-seq data. And these are things that are currently being brought up for the Cure Cloud. So I think I should stop now. It is at 50 minutes at this point. And I will make the slides available. Yuri can send them out. I think he may have them already, or Lance may have them already. And I will stop at this point because Yuri mentioned to stop at around 50 minutes.
And we do have one question that came in, and hopefully I get it across correctly. So Katie, keep me honest if I don't. But when you look at, like you showed in some of those last slides, the genomic data or some of the other kind of newer things, like even some of the patient-reported outcomes. Her question was, is it better, in your opinion, to add some of that new focus and have, in some instances, it might be incomplete data, rather than just having other fields that are more robust and perfect in how they collect things? So, is it easier to have things that are, I guess, better to collect and easier to collect than adding on some of the newer things like genomics and, as you pointed out, some of like the laboratory data, those type of things? So hopefully I got that across.
Better is the wrong word. It's not a judgment here. This is, I can tell you that, one orange is better than the other because it's sweeter and has the easier to peel rind. But that's not the case. You can't use the word better here because it's use case dependent. It's what are you trying to accomplish? And that's the question that's the one that's relevant. And you can only assert that you want to use this or that because it is something that's going to answer some clinical question or some research question that you have interest in. And if it turns out that that question is hard to answer, well, too bad. There might be strategies to make it easier, but it's not like you should just avoid the problem because it's hard. If that were the case, we never would have solved the human genome. That was hard. I think using judgment words like that are, frankly, the wrong way of thinking about it. A better way to think about it is, what questions are you trying to answer? What kinds of outcomes are you trying to establish? What are the things that are going to make a meaningful change in clinical care if you're looking for outcomes? And that's how you frame what you're trying to do. And somebody wrote, yes, it always comes down to the use case. Well, of course it comes down to the use case. I mentioned there was 42 use cases that that we identified in that paper in 2008. And you can find that paper, and maybe I can send that paper to Lance. It was all about what are the use cases of EHR data in life sciences. And it was a Pfizer paper. So in some ways it's coming home.
Good, excellent. Yuri, any other comments to wrap up? And
so I think it's just picking up on what Steve was just talking about. I think really understanding the use cases and the research questions that you want to answer is super important to be able to understand the data model that you want to be able to do this. And I think Dr. Labkoff is one of the world leaders at sort of getting it right and developing. There's lots of people doing registries, but sort of haphazardly. And I think there's informatics is about a systematic way about looking at a problem and trying to find the right methods and approaches to solve it. So I want to thank Dr. Labkoff for sharing experience. The MMRF cloud is really one of the largest and most, he's been a little humble on his and short on time, but it's really one of the best designed systems that's out there. And so encourage you to take a look at that and some of the other examples that he's given. So thank you very much, Steve. And Lance, let me pass it over to you because I think we have a 5-minute break and then we can come back. We will have Dr. Chris Shute and Dr. Bates will actually join us for the last 30 minutes as well to talk.